Let's investigate the decay of the boson minus, or W boson. Represented as an ordered pair is 3/2, comma, -3. And graphically is a anti-V self-relating Rishon associated with a T self-relating Rishon, which altogether will be associated with a particle-antiparticle pair. As you can see over here, we have the anti-V self-relating assembly and the anti-T self-relating assembly associated with 3/2, comma, -3. And then we have a anti-muon neutrino with its assembly and a muon assembly with its assembly being 3/2, comma, 0 and -3/2, comma, 0 respectively. Now, the boson minus represented here and as an ordered pair here combined with the muon neutrino assembly will give you a muon assembly, so that we can see that one possible decay of the boson minus is the anti-muon neutrino and the muon neutrino, which you can see represented over here, the anti-muon neutrino and these two together, the boson minus with the neutrino, represents a muon assembly. By changing the particle-antiparticle pair, we can change the product of the boson minus decay. So we will increase the T by 1 and decrease the V by 1, thereby now changing the particle pair to a D and anti-D, and thereby having the decay products now to be a D quark and a anti-U quark, as we can see over here also. We now have changed one of the Rishons so that we have a D quark and an anti-D quark, and now this anti-D quark and the boson minus form a anti-U quark. And so we've changed the decay products of the boson minus, or W boson. We can change the particle-antiparticle pair again by decreasing the V and increasing the T, so that now we have U and anti-U particle pair, which will make the decay product of the boson minus, or W boson, a anti-U quark, and a D quark. We look over here graphically, we have an anti-U and a U quark with the boson minus. And now this U quark right here with the boson minus will form a D quark, as indicated over here also with the ordered pairs and their assemblies. Again, we can change the particle-antiparticle pair and produce different decay products for the boson minus. And so we will increase the T to 3 and decrease the V. And now we have a muon and anti-muon, and which will give us a decay products of a muon and an anti-muon neutrino, which we can see over here. Now we have a muon and an anti-muon. That anti-muon combined with the boson minus, of course, gives you anti-muon neutrino. And last but not least, we'll see what happens when we exchange the components of the boson minus with components of the anti-muon and the muon. Specifically, we will take the anti-T self-relating rishon and exchange it for this alter-relating rishon in the muon, and this anti-V self-relating rishon and exchange it for this alter-relating rishon in the anti-muon. We will see over here that's equivalent to changing the V, increasing it to minus 2 divided by 2, or 1, which will give us an electron. As we'll see, we'll take this self-relating anti-rishon and it will exchange with one of these alter-relating rishons. And here, this combination will allow us to exchange this self-relating anti-V rishon with one of these alter-relating rishons to give us a anti-neutrino. We can see that exchange graphically over here. The boson minus, W boson, is now a boson 0 because we exchanged the alter-relating rishons with the components of the W boson. And now we have the decay products of the W boson as an electron and an anti-neutrino, which are the most probable decay products of the W boson.